Today we are going to study 1D symmetric box. Okay. So symmetric means we will take the box like this. It is also infinite box. This time here we will write 0, here minus L by 2 plus L by 2. So the separation between them is still L. Inside potential is 0 and outside potential is infinite. That is 1D symmetric box. If you would write in this way, you can write Vx is equal to 0 if it is between minus L by 2 minus L by 2 to x is greater than minus L by 2 less than smaller positive L by 2, and it is infinity elsewhere. So let x at minus L by 2, x is greater than L by 2 or equal to. At equal also there is infinity, as we can see here. So in the same way we will write the Schrodinger equation minus h cross square divided by 2m d square psi by dx square is equal to E psi. Okay, again we will do the same thing. We will assume k is equal to root 2 me upon h cross square. Yes. All these things are just the same because the Schrodinger equation is same now, because potential is again 0 inside this. So in this inside region we are solving this. Outside already the wave function is 0 because of the infinite repulsion. Inside we are solving and the equation is just the same as before. Okay, what is changed? Only the boundary conditions are changed. All the other things are just the same. So we will get the same solution as the solution of this equation, d square psi by dx square plus k square psi equal to 0, and then we will get psi is equal to a sine kx plus b cos kx. So this is the same solution as the asymmetric potential. So if this is symmetric potential, then obviously the one that we have studied before that there is the asymmetric potential, right? Here it is asymmetric because at x is equal to 0, which is origin, from that if you look at the left hand side is not equal to the right hand side, because from this origin left hand side is infinite potential and at right hand side there is 0 potential, so it's not equal, so it means it's not symmetric. So this is asymmetric potential. Now let's come back to our symmetric potential. So boundary conditions now we are going to use. In order to find out these arbitrary constants. So psi at x is equal to minus L by 2, wave function is 0, and psi at x is equal to plus L by 2, also it's equal to 0, because the wave function has to vanish at the boundaries because of the infinite potential. Just like the outside wave function is 0 and inside it can be anything, but here it has to be 0 because of the infinite repulsion. Here also it has to be 0. So just try to put this, so you will get this 0 is equal to a sine minus kl by 2 plus b cos minus kl by 2 is equal to 0. So this will become sine minus theta is equal to minus sine theta. So you can write it like this also, that minus a sine kl by 2 plus, but cos minus theta is cos theta only. So plus b cos, because cos is an even function and sine is an odd function. That's why. So equal to 0. This is the equation we get from the first boundary condition. Then we can use the second boundary condition. From the second boundary condition also you can write then the equation, that will be a sine kl by 2 plus b cos kl by 2 equal to 0. This is what you get. Now you can see in above equation and this downside equation, there are same quantities like a sine kl by 2 and there is cos kl by 2, right? So you can understand this equation by writing like this. This first equation is similar to the minus c, or let's write in this way. First equation is similar to like minus x plus y equal to 0, right? This is x, that is y. And then the second equation is similar to x plus y equal to 0. So here you can say that x is equal to y. From here you can say no, x is equal to y. And here you say in the next equation x is equal to minus y. How is it possible? X is equal to y also and x is equal to minus y also. It means that y is equal to minus y, right? So it means y is equal to minus y. That is only possible if y is 0, right? Otherwise it's not possible. 2 cannot be equal to minus 2. Any finite quantity cannot be equal to its minus sign. So that's why we conclude that it means y is equal to 0. And then y is equal to 0, then from this first equation x is equal to y, x will also become 0. It means that x and y, both of them are equal to 0. It means that in the real equation a sine kl by 2 is equal to 0 and b cos kl by 2 is also equal to 0. both of them are equal to 0. Okay. Now we will write all the possible solutions. What are the possible? So both of them cannot be equal to 0. If both of them will become, both of them are equal to 0, but both of these coefficients cannot be equal to 0. Like if A is 0, then B cannot be 0. Because if A and B both will be equal to 0, then this wave function will be vanished. Right? This net wave function we have written, this will be vanished. Which is not possible because particle is there inside the box, that we know. So if A is equal to 0, then cos KL by 2 equal to 0. So we write if A is equal to 0, then cos KL by 2 equal to 0. And if cos KL by 2 equal to 0 means KL by 2 is equal to n pi by 2. Because you know that cos becomes 0 for the angle pi by 2, 3 pi by 2, like this. So n, you can write that here n is odd. N is odd integer. You can write odd number. So 3 pi by 2, 5 pi by 2, like this, right? If you write 4 pi by 2, then it will become 2 pi, and for 2 pi cos is not 0. That's why we are choosing only odd numbers. Okay, so from here KL is equal to this, KL by 2 is equal to n pi by 2, and K value you can write as n pi by L. K will become n pi by. So that is the first type of solution. Now the second solution is this. The second type of solution is this, that if, just say that if B equal to 0, then sin KL by 2 has to be 0. So if B is equal to 0, so if sin KL by 2 equal to 0 means KL by 2 is equal to n pi. But if I say that n is an even number, then you can write KL by 2 is equal to n pi by 2 also. N is, you can check that, because if n is even means like it is 2, right? So it will become 0. Now 2 by 2 is pi, and sin pi is 0. If n is 0, then it is 0. So for 0 also sin is 0. For 4 it is 0. 4 divided by 2 is 2 pi. So 2 pi is 0, right? So that's why if n is even number, then you can write n pi by 2 again. Why do I want this? So I can get the same form for both of these solutions. That's why. So 2 is cancelled with 2. Here again you can write k is equal to n pi by n. But this n is even number. So you can write the wave function like this. You know that either A is 0 or B is 0, right? So if A is 0, then you can write in terms of B. So now I am writing solutions. If I take this first condition, that if A is equal to 0, then the solution that you will have will be equal to this psi n, will be, because B is not 0 now, and cos n pi x by L, right? Because k value I have written from there, n pi x by L, and n is what? From here, if A is equal to 0, then n is odd number. So n is odd number. One, 3, 5, like this. So that is the one type of wave function. From the second kind of, you can write that if B is equal to 0, then you can write psi n is equal to A sine n pi x by L, where n is even number. So these are the two functions we get, two eigen functions we have got from here. Okay, eigenvalue is already done because k value we have found now, so that we are going to equate with this, where we have written k is equal to root 2 m upon h cross square. So because k value is same for both of them, so it will both of them, you can write together the energy. But these eigen functions are different. Energies will also be different, but the form is same: m square pi square h cross square divided by 2ml square. So that's it. These are the two wave functions, sine and cos. One is odd function, one is even. So there are two solutions here: odd solutions and even solutions, right? So let us write for the ground state now. And again, one more thing, that these coefficients will be removed using the same method, normalization. And because the function is same, sine, again the normalization constant will be the same, right? So normalization constant then will become root 2 by L. So here also you can write root 2 by L. Instead of B also, then you can write 2 by L. If you don't want to erase this, you can write in the next lines that B is equal to root 2 by L. This also, if you calculate the normalization for this function, you'll get the same root 2 by L. So here only I am writing to save some time, root 2 by L from the normalization. Now we'll write the ground state wave function. For ground state wave function, n will be equal to 1, because that will give you the minimum energy, because still energy is the same, En. If you want to write energy, here you can write for En is n square pi square h cross square divided by 2 ml square. Why? Because the same k value is there n pi by l. So if you'll put it there in the above equation, here in this equation you will get the energy value. I'm sorry. Hello.
State first excited signal finding first excited signal variations രണ്ട് വേവ് ഫംഗ്ഷൻ ഒന്നിൽ n ടേംസ് മാത്രമേ അതുപോലെ എനർജി ടേംസ് മാത്രമേ മറ്റേത് എനർജി
Okay, so energy value we will write as this. N can be 1, 2, 3, 4, like this. Anything. Okay, depending on for which state you are writing. If it is n is equal to 1, then it will be that odd, this cos 1, right? So for that you will write the energy E1. It will become clear now. For the ground state n is equal to 1, so the ground state energy will become E1 pi square h cross square divided by 2 ml square. Okay, and the ground state wave function psi 1 x will become root 2 by l, and because it's cos, so cos pi x by l. The first excited state is write n is equal to 2. Why am I calling this as first excited state? Because this has energy more than the minimum energy. Minimum energy you will get for n is equal to 1. So for whatever n you get minimum energy, that is always ground energy, ground state energy. Then you just keep increasing. What is the next possible energy? That will be of the first excited state only. Okay, so n is equal to 2, it will be the energy of the first excited state will become 2 square 4 pi square h cross square divided by 2 ml square. Now generally where students make mistake, and this is a silly mistake, that when they are asked first excited state, then, and this is the question, so question like this topic is a little bit easy, so they get excited in the exam. They also go in the first excited state and they write, okay, it is first excited state means n is equal to 1, right? So let the particle be in the excited state, you don't get in the excited state. If it is first one, then you write n is equal to 2 because it is starting from ground. Okay, so from 0 you are going to count. So 0, 1, 2, 3, ground, first, second, 3. And as I could see the smile on your faces, so I know that you might have made the same mistake before somewhere while solving assignment questions or something. And it changes also. That is also one thing. Like when we study the the oscillator SHM. So then it starts from 0. Here it is starting from n is equal to 1. There it starts from 0. So n is equal to 0 is ground state there. Okay. So there the first excited state means n is equal to 1 only. So be careful in this E2, and psi 2x will become root 2 by L two pi x by. So this will be the states. You can draw the ground state also. This is the ground state, so I have a little space here. So it is minus L by 2 plus L by 2. This is 0. So because it is a cos function, right? The ground state is a cos function. So if I draw a line here, symmetric line, it's not symmetric. So you know cos starts from maximum value 1, right? From the 0 it starts from 1. It means if x is 0, then it is 1. So it will be here and it will become 0 here like this. And the same thing will happen in the other side. So this is the ground state. You can draw. Other things are just clear. So that is the asymmetric potential. We have found the eigenvalues and we have got the eigenfunctions. So means we have the solution. It means these are the possible energy levels that particle can have, and these eigenstates are the possible states in which that particle can be in whenever it is in the this box, symmetric box. You can see one thing also here, that the energy is not changing, right? Energy levels are just the same as before. So because something physically is not changing, no? Because it is still the box of length L. Okay, it is still the box of length L. Now how does the particle know that where to start, where is the 0, where is the origin? Because origin is not some physical thing, right? So the particle doesn't know that this is the origin or that is the origin, or this is symmetry or that is symmetry. The particle is like rotating, the moving in the same way in the when the box is there or when the box is here. What difference? Particle doesn't know that. So the energies are just the same. And this energy eigenfunctions form is changing, so because of the boundary condition, so that becomes 0 at both of the boundaries. That's it.